Final review, Unit 5. Example 1. Two numbers are consecutive, positive, odd integers. So whenever we're dealing with problems like these, I like to always do like a generic example of what are two consecutive odd integers. 1 and 3, okay? So then your first number is always your x. And your second number is always x plus something. So in order to get from 1 to 3, we would add 2. So those are my two variables, x and x plus 2. So when we go through and read, it says the square of the larger. Well, which one's larger, x or x plus 2? Okay, so the square of that would be x plus 2 squared. What does is mean? Equals, good. And then it says 3 less than. Whenever you see this word than, it means you need to start at the end and write that part first. So what would I write for 12 times the smaller? 12x less than is minus and then 3. Okay, and then it asks us to find the sum of the two positive odd integers. So we first need to find what the integers could be. How will I do that? Good, you first need to multiply this out, and you can use the box method if you want to. So to the side, I'll go ahead and do that. So we have x and 2 and x and 2. When we multiply, we get x squared, 2x, 2x, and 4. Those are our like terms. So that means that x plus 2 squared is actually x squared plus 4x plus 4. And that equals 12x minus 3. What would be our next step on this problem? Good, move everything to the left so you can factor. You want it set equal to 0. So I'm going to subtract 12x and add 3. Okay, so when I go through here now, I have x squared minus 8x plus 7 equals 0. So we need to factor that. What multiplies to be 7 and adds to be negative 8? Good. X minus 1 and x minus 7. Those add to be negative 8 and multiply to be a positive 7. And when you set those equal to 0, you find that x equals what? Okay, so at this point is when we go back to our original problem, and it says consecutive positive odd integers. So are these both positive odd integers? Yes. Okay, normally one of them cancels out. Every once in a while, one of them doesn't cancel out. In this case, it doesn't. So we're going to have two different sets of answers. Okay, so if we start with 1, if x was 1, what's our second number? 3. So one of our sets of numbers is 1 and 3, and if you take the sum of that, what is the sum of that number? 4. Because at the end it asked you to find the sum of the two positive odd integers. So 1 plus 3 makes 4. Okay, then we're going to have a second answer. Okay, we have 7. So if x is 7, if we plug 7 in for x, my other number will be 9. And if we add those together, that equals what? 16. Okay, so I have two answers for this problem, and it's 4 and 16, because those are my two sums for my numbers. Questions on example 1. Okay, example 2. We're dealing with i's. Who remembers the most important thing about i's? Anthony.
2 of them are together, they're negative.
Good. I squared equals negative 1. Okay, you need to remember that. Okay, so when we do this problem, we're just going to distribute 7i through. So 7i times 2i is 14i squared. But I squared is what? So we have 14 times negative 1, which is negative 14. And then we distribute 7i times 5, which is, so you have negative 14 plus 35i. And when you're writing your answer, you always want your real part first and then your I part, and it's already written that way, so we're good. Questions on 2? All right, example 3. What is wrong with example 3? You have an I in the denominator. We cannot have i's in the denominator. Who remembers how to get rid of the I in the denominator? You multiply something by something, it starts with the C. Anybody remember? Conjugate, good job. You multiply by the conjugate because there's adding and subtracting. Whenever there's adding and subtracting, you have to multiply by the conjugate, which is the opposite. So since this is 4 plus I, we're going to end up multiplying by 4 minus I to the top and the bottom. If there was like a 4I and there wasn't adding or subtracting, then you would just multiply by I. Okay? So when we multiply this, you can use your box if you want to on this to make sure you don't mess up. So if I go to the side here and do that, we have a 4 and a negative I and 4 and a positive I. So 4 times 4 is 16. And then we have 4 times I is 4I. 4 times negative I is negative 4I. And then negative I times I is negative I squared. But what does I squared represent? So that means you have a negative 1, which makes a positive 1. So be careful. So this I'm going to cancel out, and I'm just going to write a 1 here. So we have a 1 and a 16. Those canceled. And so what is my denominator? 17 is correct. And then we multiply 3 through. 3 times 4 is 12. And 3 times negative I is... And if you could reduce, you would, but we can't. So that's our answer. Questions on example 3? Okay, example 4. We want to end up making this so that it ends up just being either a single I or we get rid of the i's. Does anybody remember how we end up changing I to the 13th? What do we do? Oh, so you just write it out 13 times? Is that what you're saying? Okay. That is one way. You can totally do that. You could write out all 13, and then you know that 2 i's end up making a negative 1, and you can go through that way. The way that I always do it is I know that I squared is negative 1. So, but this is an odd number. And so I'll write this as I times I to the 12th, because 12 plus 1 makes 13, right? And then I can simplify I to the 12th, because I know that I to the 12th is I squared to what power? The 6th power, right? Because 2 times 6 is 12. Do we agree? And then I know that I squared is actually what? Negative 1. And what is negative 1 to the 6th power? Positive 1. Negative 1 to the 6th power ends up being a positive 1, right? Because, okay. So that means that I end up, I need to not forget this negative 5 either. I have negative 5 times I times 1. So what does that end up simplifying to be? Negative 5i is the answer. All right, and there again, there's more than one way to do it. You do not have to do it this way. It's up to you. Okay, any questions? Yeah. So remember that, so I to the first is I. I to the second power is negative 1. I to the third is I times negative 1, right? So I to the third is negative I. I to the fourth ends up being negative 1 times negative 1, which is a positive 1. And then it'll keep going in that same pattern. Okay. Example 5. What will I do on example 5? You could set it equal to 0, but see how there's no plain x term and we're not going to be able to factor? It's easier just to try to get your square by itself. So what would I do in order to get the square by itself? Very good. So subtract 40 to both sides. We have 3x squared equals negative 36. Then I divide by 3 to both sides. We get x squared equals negative 12. To get x by itself, we take the square root of both sides. Anytime you take the square root, your answer is going to be what? Plus or minus. Can this break down at all? It breaks down to, good, 4 and 3, and then 4 is 2 and 2. So I have a pair of 2s with a 3 left over. And what do I do with that negative inside? Bring it out. So what will my answer be? Good. Plus or minus 2i root 3 is correct. Questions? Okay, example 6, you're just finding the sum. So all we're doing is combining like terms. Okay, but before that, you need to get rid of the parentheses. Well, there's nothing to do with this parentheses, so I just have 7 plus 2i. When you distribute a plus, it doesn't change anything, so I have plus 3 and a minus 4i. And then when I distribute a negative, it becomes a negative 4 and a positive 7i. Okay, so then we're just going to combine our like terms. So I have a 7, a 3, which makes 10, and 10 minus 4 is 6. 2i and negative 4i is negative 2i, plus 7i makes positive 5i. And that's our answer. Questions? Okay, moving on to the back. What will I do on example 7? Box method. Normally I'd have you do this on your own, but we're running out of time today. So let's go ahead and do our box together. So we have 3 and 2i and 5 and negative 4i. Eddie, when we multiply, 3 times 5 is 15. 3 times negative 4i is
negative 12i.
2i times 5 is
10.
10i. Good. And then 2i times negative 4i is
Negative 8.
I squared. And I squared actually represents what? Negative 1. So negative 8 times negative 1 ends up being a, so I'm going to cross all that out and write a positive 8. So we have 8 and 15 that we add together, which makes 23, right? And then 10i and negative 12i makes a negative 2i. Remember that we always write the real part first and then the I part. Okay? So that is the correct answer. Okay.